Record. Okay, I think this is being recorded now, so I just want you to know. This particular lesson is about two things, no? Number one, it's about monotone sequences. When you say monotone sequences, these are sequences that whose terms go in one direction. So for example, the terms are going to the right, meaning to say it's increasing, or if the terms is going to the left, it is said to be decreasing. A sequence that's either decreasing or increasing is called a monotone sequence. And then afterwards, we will be studying subsequences. Subsequences are sequences that can be found in a larger sequence. Anyway, so let's start with the first definition. So a sequence x sub n with terms x sub n is said to be increasing if the n plus 1 term, n plus 1 term dominates the nth term for all n, meaning to say, when n is 1, x sub 1 is less than or equal to x sub 2, dinodominate na x sub 2 sa x sub 1. Then x sub 2 is being dominated by x sub 3, x sub 3 is being dominated by x sub 4, and so on. So the larger the subscript, the bigger the term. However, in this definition, no, you see that the inequality that I'm using is less than or equal, meaning to say, I am allowing for terms to be equal, no? For example, yung first up to third term pwedeng pare-parehas. Ang importante, hindi bababa yung value habang lumalaki yung subscript. Now, the value can stay for a while, but it has to go up or it can stay. No? So, ganun ang increasing. Kaya nga, in some other books, yung ganitong definition, ang ginagamit na term ng mga authors ay non-decreasing. You may hear the authors say a sequence is non-decreasing kasi I think that's more appropriate. Kaya lang, ayoko namang mag-define ng something in the negative sense. So ayokong sabihin na sequence is non-decreasing if kasi negative yung non, no? On the other hand, a sequence is decreasing if the inequality if this inequality holds for all n. Ang pinagkaiba lang nito, yung inequality symbol natin ay baligtad ang order. Again, you can stay or you can decrease the value as the subscript increases. Now, sometimes if you strictly want to say that x sub 1 is strictly less than x sub 2, x sub 2 is less than x sub 3, and so on, you can say that the sequence is strictly increasing. You may hear me say the word strictly or the adverb strictly. Okay? Strictly decreasing kung ito ay greater than. A sequence that's either increasing or decreasing is said to be monotone. Doon kinuha yung word na monotone. So far, do you have questions before I proceed? Do you still follow?
Yes, sir.
Okay. Ayan, may tanong si Eric. Kapag ang terms daw ba ay all equal, are they considered increasing or decreasing? If your sequence is constant, I think that's what you mean, Eric, no? If your sequence is constant, what? 2, 2, 2, 2, 2, 2, 2, 2. Oh. In that case, it's both increasing and decreasing as per our definition. But a constant sequence is not strictly increasing, if that's what you mean to say. Kasi yung word na strictly ginagamit ko, if I really mean that the values increase strictly. But in our definition, we accept a constant sequence to be both increasing and decreasing. In fact, a sequence is both increasing and decreasing if and only if it is a constant sequence. Well, so in pictures, this is what you will see whenever we speak of an increasing sequence, or in fact, this is strictly increasing now. And by a decreasing sequence, this is what you should see. As n approaches infinity, the terms are getting smaller and smaller. For example, the sequence defined whose n term is n squared, the terms are 1, 4, 9, 16, and so on, is increasing. In fact, it's strictly increasing. To verify that it is really increasing, take note that for all n squared is strictly less than n squared plus 2n plus 1. Kasi yung 2n plus 1 na to ay positive, right? For all n greater than or equal to 1. So if I add it to n squared, the value will increase. But that thing is the square of n plus 1. Meaning to say, kung tatawagin mong x sub n yung n squared, itong term na ito, ito yung x sub n, ito naman yung x sub n plus 1. As you can see, x sub n is less than strictly to x sub n plus 1. Kaya nga yung n squared ay strictly increasing. And with this, if you take the reciprocal of n squared, you get 1, 1/4, 1/9, 1/16. Remember, if you take reciprocals, the order reverses. So in this case, this sequence is now strictly decreasing. Ayun nga, dahil nga ito ay totoo, pag may reciprocal, they are both positive. Mangyayari yung 1 over n squared will now be greater than 1 over quantity n plus 1 squared. So that proves that this sequence is strictly decreasing. On the other hand, by the way, these examples are monotone sequences kasi they are either increasing or decreasing. So they are both monotone. Wait lang. All right. So on the other hand, the sequence whose n term is sine of n, sine as in the circular or trigonometric function sine. This is not monotone. No, as you can see, if I plot the terms of sine of n from 1 to infinity, you will get these values. When n is 1, yan. Ganyan ang itsura niya. As you can see, ito yung sine of 1, sine of 2, sine of 3, sine of 4, sine of 5, and so on, 6, 7, 8. Actually, these points, given these points, there's an underlying continuous function that that follows the pattern. Ito yung y equals sine of x if you try to sketch it using this So Eric is asking, sir, kapag trigonometric function po, kapag ganyan ang form, bali in radians po siya, no sir? Yes. In calculus, trigonometric functions are assumed to have real inputs, or the domain is a subset of the real number line. So angles are measured in radians in calculus. Lahat ng mga formulas niyo sa calculus holds, especially when it comes to trigonometric functions. It is because of the assumption that x is measured in radians. If x was measured in degrees, for example, yung derivative ng sine x may no longer be equal to the cosine x for that matter. Anyway, so let's continue. So ang bida sa lesson na ito ay yung tinatawag na monotone convergence theorem, or the MCT. Kasi this tells you precisely when is a monotone sequence convergent. Remember, generally or in calculus, we are really after sequences which are convergent because these sequences have limits. No? Sa calculus, limits are all that matters, right? So, tanong natin, kailan ang monotone sequence magko-converge? It turned out that the criteria that we need, or the criterion that we need for a monotone sequence to converge is kind of simple. What we only need to happen, or what a monotone sequence should be para siya maging convergent ay yung pagiging bounded. So meaning to say, being monotone at the same time being bounded will guarantee convergence. Ganun lang kasimple. Diba generally, if you can remember the previous lesson, convergent sequences are bounded, but not all bounded sequences converge, right? We have a lot of examples. But if your bounded sequence is monotone, or if the monotone sequence is bounded, you can already guarantee convergence. In other words, monotone sequences are easier to study than general sequences because you only need to check for boundedness to guarantee that it has a limit. Do you understand me on that? Okay. Yeah, but if, for example, your sequence is increasing, if your sequence is increasing, wherever it starts, no, lagi siyang bounded below. Ang lower bound niya yung first term, diba? The first term, if their sequence is increasing, no, yung first term will always be a lower bound. Kaya magiging bounded siya. Ang kailangan mo na lang i-check kung siya increasing ay yung pagiging bounded niya above. Kasi pataas siya ng pataas, you don't know where it goes. Kung yung increasing sequence mo ay bounded above, no? If you collect all the terms in this set will already be bounded. Or, well, it's bounded above. So by the completeness axiom, it has a least upper bound. Yung least upper bound, if you call that alpha, it turned out that to that least upper bound, the sequence will converge. So you may ask, oo nga sir, convergent ang increasing na sequence kung siya ay bounded above. Ang tanong, saan siya magko-converge? Magko-converge siya doon sa least upper bound ng mga terms. If you can remember the least upper bound. Again, pag sinabing least upper bound, among the upper bounds, itong pinaka maliit. Okay? No number less than that, or no number less than alpha can be an upper bound. That's what you mean by a least upper bound. Parang imagine niyo siya yung pinaka least upper bound. Parang imagine siya pinakapangit sa lahat ng mga magaganda. Charot. Joke lang yun, of course. Naku, this is being recorded pala. So let's avoid remarks like that. Anyway, on the other hand, mali yung number, pagkakatype ko sa number 2, no? I'm so sorry about this one. Ito naman yung case na si x sub n ay decreasing. Okay. If the sequence is decreasing now, you don't have to worry about an upper bound. So the first term will always be an upper bound. You just have to worry about a lower bound, the existence of a lower bound. So if the sequence is decreasing and it has a lower bound, or in other words, bounded below, to where should it converge? Ang gagawin mo, collect all the terms in a set. The completeness axiom will guarantee that the infimum will exist, and to that infimum, the sequence will converge. Do you understand? In pictures, wait now. In pictures, this is an increasing sequence. But this increasing sequence, although it increases, it's bounded above. In fact, it will converge to the least upper bound of all the terms. Yan, ito yung least upper bound ng mga terms. Kapag naman decreasing, ganyan ang itsura, no? Right? So let me, anong gagawin ko dito? Ay, decreasing to, no? Mali ako, sorry. Paano ba ito i-paste? Ay, umiyaman na. Decreasing ito. Wala. Yan, ganyan siya in pictures. So I think we will prove this kasi this is one of our major theorems in advanced calculus. Kaya ako siya pinapangalanan simply because it's going to be used a lot of a number of times in the future. Pero ang ipoprove ko lang yung number 1 I'm leaving number 2 for you to do it kasi medyo parallel siya sa number 1. So for example, x sub n are in this proof, let's assume that the sequence x sub n is increasing and that the set of the terms is bounded above. So that's what those are the assumptions. We will prove that if alpha denotes the least upper bound, which already which we know to exist by the completeness axiom, we will show that the sequence actually converges to that least upper bound. Again, proofs of convergence always normally begins with let epsilon be greater than 0. So again, what do we need to do? In our minds, no, in our minds, so this is what we wanted to do. I need to find. Huwag na sabihin, I need to find kasi baka hindi mo makita. I need to show that there exists a natural number n so that the distance of x sub n from alpha can be made less than epsilon as long as the subscript or the index n is chosen to be at least big N. So that's what we mean by being convergent, no? So how do we guarantee that such N exists? Remember that in order to guarantee that such N exists, you don't really need to find an actual value for N, no? Sometimes or normally we use the Archimedean property or sometimes whatever, no? In this case, Archimedean property is not going to be used. We're going to use something else. Here, take note that if you subtract epsilon, because epsilon is positive, if you subtract epsilon from alpha, you get a number less than alpha. Therefore, because alpha is the least upper bound of the terms, alpha minus epsilon cannot be an upper bound for the terms. Hindi ba? Kasi alpha is already the least upper bound. So if you subtract something positive from that, it's not going to be an upper bound anymore. So as per definition of an upper bound, if alpha minus epsilon is not an upper bound, that means to say that the set already contains an element that's bigger than alpha minus epsilon. Meron ng isang term yung set na ito na mas malaki dito. Tawagin natin yung term na yun to be x sub big N. Kung ano man yung subscript niya, yun yung big N na mag-work. Makikita niya. Let's see. So I will now take a little n, an index n, bigger than or equal to capital N. I will now show that, having assumed this, we will now show that the absolute value of x sub n minus alpha is less than epsilon. But, as you can see, since the sequence is increasing, hindi pa natin nagagamit itong property na ito. No? Since the sequence is increasing, the bigger the index, the bigger the term. So if you compare x sub n and x sub big N, which one is bigger? Of course, x sub n. X sub little n. So the bigger the index, the bigger the subscript. Implication of being increasing. So if I now take the absolute value of x sub n minus alpha, remember alpha is the least upper bound of this set. So if alpha is the least upper bound, it's an upper bound in the first place. So sino mas malaki sa x sub n at alpha? Of course, alpha. Kaya yung absolute value nito should be alpha minus x sub n. Right? Okay. But from this inequality, no, if you have this inequality, mag-multiply ka ng -1 on both sides, magiging ganyan yan. Tapos mag-add ka ng alpha, you will get this. Kaya this was guaranteed. Right? So, now using this inequality, if x sub capital N is greater than alpha minus epsilon, yung alpha minus x sub n is less than epsilon. So I think that's what we needed to do. That proves that x sub n converges to alpha as claimed. So na-prove natin that if a sequence increases and it has an upper bound, it converges to the least upper bound. Did you understand? Do you follow me so far? Any other reactions? Okay, thank you. So I think let's now illustrate. Now, although the proof might seem simple, no, but the applications are really nice. I have considered these examples because these are really important in calculus. Let's consider the sequence E sub n. The sequence E sub n has nth term 1 plus 1 over n quantity raised to n. So for example, ang E1 natin, sige nga, mag-compute tayo for example. Halimbawa, ang n natin ay 1, so that's 1 plus 1 over n, that's 2 raised to 1, 2. When n is 2, 2.5 squared. Ano ba yung 2.5 squared? Ang hirap naman. 6.25? Ay, ano pinagsasabi ko? Ano ba yung 2.5 squared? Oh my gosh, nakakahiya. I don't have a calculator. Meron ako ditong calculator. Wait lang ha. Siyempre, hindi nyo nakikita yung calculator. Hindi siya sa background ng ano ko. Ay, ano ba sinasabi ko ba? 2.5. 1.5. Kaya pala na mali. 1.5 squared pala. It's 2.25. Tapos 3. What is that? Can you calculate for me? 1. Hirap naman. 1 plus 1/3 raised to 3. 2.3703703703, etc. Ganyan. So, ganyan yung sequence, no? In fact, if I plot some of the points, we will not do the. This is what you will observe. Yes, thank you. Nasa chat box pala yung mga tulong nyo. Ngayon ko lang nakita. Thank you for your help. But I already asked the computer to do the calculations and I let the values be plotted in the x and y plane as shown. So what can you say about the sequence? Well, sabi pala, show that the sequence converges na, no? Ang tanong ko, to where will it converge? Approaches 2.718 something, no? Paano man, napaka-specific naman ng 2.718? How did you come up with that value, Eric? Euler's number, sir. Spoiler kayo, ha? Halimbawa, how would you know that this? Kasi madaling if you are just eyeing a sequence, when I say eyeing, tinitignan mo lang yung sequence. If you are just looking at the sequences, madaling makita nagko-converge siya sa 1, nagko-converge siya sa 2, no, sa 3, kasi palapit ka ng papalapit sa line yun. Pero in this case, no, it seems to converge but at some number between 2 and 3, no? So you cannot really tell exactly what the limit is. So yun nga, ito yung examples natin sa calculus that we know that somehow it has a limit but we cannot point out kung ano yung exact value ng limit. Well, to prove that it has a limit, this is what I'm going to do. We will first prove that the sequence is actually increasing and that it is bounded above. And with this, by the monotone convergence theorem, we can already guarantee that the sequence converges. For the increasing part, so this is what I'm going to do. I will try to expand this using the binomial theorem from algebra. Oh, what happened there? What happened is that ito siya. Ang binomial theorem talaga ganito. N taken k, 1 raised to k, 1 raised to n minus k, 1 over n raised to k. Okay? Of course, yung 1 raised to ano, yung 1 raised to something, 1 lang yan. Okay? Tapos, yung makikita nyo naman yung 1 over n raised to k is there as well. No? Itong portion na ito yung n factorial over n minus k factorial when you were younger. No? So parang ang ibig sabihin nito, sa n factorial kasi, take note, sa n factorial kasi, pag tinakbo mo yan, no, pababa, bago mag n minus k, meron mo ng n minus k plus 1. So meron kang n minus k minus 1. Palagay na natin dyan factorial. So when you divide n minus k factorial, these terms will, and these factors will cancel as shown. Kaya meron ka na lang ganito. Alright? May question ako. How many factors are in the numerator of the fraction? How many factors are there? So n factorial, it goes from 1 to n. So there are n factors. Ang tinanggal ko ay n minus k. Ilan na natira? N minus k. Ano yan? K, di ba? So, yung numerator na ito has k factors in it mula n hanggang n minus k plus 1. If you look at this factor now, meron kang n raised to k sa denominator. So, ilang n meron? K factors of n. So, therefore, kung i-ignore ko muna tong k factorial na yan, I can pair each one of these with 1n coming from n to the k kasi there are k factors, there are kn's over here. Hihiwalay-hiwalay yung n to the k na yan, tigi-tigisa dun sa bawat factor. So this is what will happen. Yung 1 over k factorial, ito yun. Yeah? Yung n over n, ito siya. N minus 1 over n, ito. Ang huling-huli, n minus k plus 1 over n. So, as you can see, there are enough n's not to distribute it one by one per each factor. Okay? So, if you are going to divide, e sub n can be expressed as follows. Ito syempre, 1 yan. Divide mo term by term, 1 minus 1 over n. Ito 1 minus 2 over n. Ang huli-huli, 1 minus k minus 1 over n. Alright? Yan. Kapag ngayon, pinalitan ko si n ng n plus 1, this is what will happen. So I'm looking at e sub n plus 1. Remember, we're showing that e sub n increases as a sequence. All right? But take note that 1 minus j over n plus 1 is strictly greater than 1 minus j over n. You know why? Kasi yung j over n plus 1 is smaller than j over n because it has a bigger denominator. So the result, when you subtract it from 1, kung ito is smaller, should be bigger. Did you understand the inequality? So in other words, this factor should be bigger than this one. This factor should be bigger than that one. This factor should be bigger than that one. In general, yung bawat terms na ito ay mas malaki sa term na ito. Kaya nga, yung en plus 1 is greater than en, proving that en is somewhat increasing. Now, this is not really surprising. Now, ang mahirap ipakita dito, bakit siya bounded above? Anong upper bound ang pwede nating ibigay? Let's see. To show that e sub n is bounded above, what we really wanted to do is we really to find one number, no? Ano kaya yung number na ito? Ano kaya yung m ang meron so that lahat ng en ay mas maliit sa m, no? Ano kaya yung m ang pwede nyo ibigay? Let's see. Let's do this analysis. Yung 1 minus j over n for whatever j is as long as it's less than or equal to n, this is less than or equal to 1. You agree? Kasi you are subtracting something positive and less than or equal to 1 from 1. So that's less than or equal to 1. Uy, ano nangyari? Lahat ito kasi less than 1 pala. Okay? Kaya itong E sub n na to, this is somewhat less than or equal dito na lang. Kasi lahat naman ito pala less than or equal to 1. So kapag in-expand mo ngayon yan, ito yan. Ito na lang matitila. Upper bound ito. At pag pinahaba ko siya, ganyan. You follow? Alright. So let's continue. Meron akong konting exhibition na gagawin dito. Pansinin niyo yung table na ito. N factorial 2 to the n. Let's start with 0, 1, 2, 3, 4, 5. All right. When n is 0, this is 1, this is 1. So at the beginning, they are equal. When n is 1, this is 1, but this one is 2. When n is 2, this is 2, but this is 4. So as you can see, the beginning, 2 to the n, is kind of accelerating faster than n factorial. When n is 3, this is 6, and this is already 8. No? But the moment n hits 4, n factorial is already 24. This one is just 16. N factorial is now 120. And now, 2 to the n is 32. So kung papansinin niyo yung pattern, no, between these two. So umpisa lang magaling yung 2 to the n. That's what I wanted to tell you. So umpisa lang siya nangunguna. But as n steps at 4 and beyond, you see that n factorial already will dominate 2 to the n, and 2 to the n will never, what do you call this? Reach n factorial anymore. Using the fact that k factorial dominates or exceeds 2 to the k for k greater than or equal to 4, yung 1 over k, ano yung way? Huwag nyo nang pansinin ito. Yung 1 over k factorial then is less than 1 over 2 to the k. Diba? For k greater than or equal to 4. So kaya, for example, yung 1 over 4 factorial, it will be less than 1 over 2 to the 4. Yung 1 over 4 factorial, yung 1 over 5 factorial, it's going to be 1 over, less than 1 over 2 to the 5th. And so on, as long as n is greater than or equal to 4. Kaya itong bound na ito is less than this. You understand? Na meron akong number dito, 1 lang ito, plus 1, that's 2, plus 1 half, 2.5, plus 1, 6, I don't know. I think kinalculate ko siya. Ayan. Kinalculate ko, itong sum na ito, I get 8 thirds. And then from here, I simply factored out 1 over 2 to the 4 over here, there. So you're left with 1 plus 1 half plus blah, 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 plus 1 over 2 to the n minus 4. Okay? Meron akong property from algebra na gagamitin. If I have something like this, hindi ba, if a is not 1, if I multiply 1 minus a, I get 1 minus a to the n. Is that correct? I think this is one among the special products that you have learned, right? And because 1 is not a, yung sum na 1 plus a squared hanggang a to the n minus 1 is 1 minus a to the n over 1 minus a. Tama, no? So when you look at this, ang a mo dito seem to be equal to 1 half. Tapos ang n mo ay n minus 4. Diba? Ano mangyayari dyan? What the hell? What the hell has happened? Oh, hindi ko pinakita. So let me show you what happened over here. Ito ngayon, equal siya sa 1 minus 1/2 raised to n minus 3 over 1 minus 1/2. Okay? But 1 minus 1/2 in the denominator is equal to 1/2. And therefore, this is 2 times 1 minus 1/2 raised to n minus 3. But you know, kahit na ano pa ito. Let me emphasize this one. Kahit ano pa to, that is just less than 1. Okay? Kaya ito, less than 2. Kaya lahat ito, no? Lahat ito, this is nothing but a number less than 2. Kaya meron akong ganyan. So I get the following upper bound or estimate for E sub n. E sub n is not exceeding 67 over 24. And when you try to use decimal representations, that is 2.791666666666, etc. In other words, none of the terms of En can exceed this particular number. Wala sa kanila ang lalagpas dyan. Kaya nga, it proves that E sub n, by the monotone convergence theorem, it proves that the sequence converges to E. For some number E, we know that that number E should be between 2 and 2.7916 bar. Pero to get a, more beautiful estimate, we just simply say that that limit E should be between 2 and 3, no, as a rough estimate. And in calculus, this limit, no, is denoted by the symbol E. Ito yung sinasabi ni Eric kanina na Euler's number or Euler's constant, no? Meron pang isang Euler's constant, don't confuse it from the other Euler's constant. Later makikita niyo. But this is normally, when we say Euler's constant, this is the first Euler's constant that it comes to our minds. Later on, I think we have a proof that this is an irrational number. No? And this is around, no, if you use your calculators to calculate E, this is around 2.718,281, blah, 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 blah. I don't know. No? That yun yung kanyang rough value. Nakita nyo yung estimate natin, no? E is between 2 and 2.7916 bar. That's kind of close. Okay? So that's the first example. Kasi sa math, sabi ko nga, no, sa calculus, there are times that we know that a certain sequence has a limit, but we cannot figure out kung ano yung exact value ng limit. No? What we instead do is we just apply the monotone convergence theorem to guarantee its existence. Let me continue. Second example. If you get a number whose magnitude is less than 1, ang ibig sabihin nito, by the way, this inequality, let me emphasize this one. This is equivalent to saying that A is between 1 and negative 1. If A falls between 1 and negative 1, then the limit of A to the n as n approaches infinity is just 0. Ano ba yung limit ng 1/2 to the n? No, 0 lang yan. Limit nung, let's say, 1 over e to the n, 0 lang din yan. Kasi yung 1 over e, if e is greater than 1, it means that 1 over e is less than 1. Diba? Tama ba? Right. So, yan yung mga particular applications niyan. We will consider cases. If a is 0, there's really nothing to prove kasi yung a to the n mo when a is 0 is just the constant sequence 0, 0, 0, 0, 0, 0, di ba? Right? So, second case, what if a is positive but less than 1? So this is what we're going to do. You will see that, or you will find that a to the n is a decreasing sequence. Bakit? Kasi kung A ay less than 1, multiply ka ng A, di ba? A squared is less than A strictly. Multiply ka ulit ng A, ang A cube naman mas maliit sa A squared. Multiply ka ulit ng A, paulit-ulit, or inductively, no? Inductively, ang A to the n plus 1 is less than A to the n. Kaya nga yung sequence mo is decreasing, and they are bounded below by 0. Kasi lahat sila positive. Hence, by the monotone convergence theorem, alam po natin na siya ay magko-converge, hindi ba? So, if we wanted to prove that the limit is 0, we just want to prove that the infimum or the greatest lower bound of this set is 0. Yun ang kailangan natin ipakita. In order to do that, tawagin natin beta, kung ano man yung infimum niyan. So, we wanted to show that beta is equal to 0. First of all, beta should be greater than or equal to 0. Why? Because 0 is a lower bound. For this set, beta is the greatest among the lower bounds. So if beta is the greatest lower bound, 0 is a lower bound. We know at this point that beta is greater than or equal to 0. In fact, for all n, because beta is a lower bound, it's less than or equal to all of this for all n. Diba? Mas maliit siya sa a to the n plus 1 kahit na anong n yan. I will try to write a to the n plus 1 as a times a to the n. Tapos di-divide ko both sides by a. So I get this. So in other words, beta over a is less than or equal to a to the n. So again, what I was able to prove is that beta over a is a lower bound for this set as well. Kasi mas maliit siya sa a to the n for all n. Right? So kung ito'y lower bound, si beta ay greatest lower bound, how do you relate them? O, kung greatest lower bound to, this cannot exceed beta. But this inequality can be manipulated as follows. Okay, then by algebra, and I can factor the beta. You get two factors over here, and their product is less than or equal to 0. A is less than 1, by the way. Kaya ang 1 minus A ay greater than 0. If the product is less than or equal to 0, what can be said about beta? Anybody? 1 minus A is greater than 0. The product is less than or equal to 0. What makes the product less than or equal to 0? Of course, kasalanan yun nung beta. Right? Kasi, ang totoo niyan, si beta ay less than or equal to 0. But when you look at this, ito, tsaka ito together, what do they imply? Anybody? If you look at the underlined inequalities, what do these inequalities imply? Yeah, beta must be equal to 0. And therefore, by MCT, a to the n converges to 0 by MCT, or monotone convergence theorem. And by the way, tapos na tayo sa unang dalawang cases. May pangatlong case. Pag naman si A nasa kaliwa ng 0. Yan. But this is no longer a problem anymore. Alam niyo bakit? Pag kasi si A ay less than 0 but greater than negative 1, ang absolute value ni A nasa gitna ng 0 at 1. By the previous case, anong limit nito? Anong limit nito? Nung difference nung a to the n at 0, maging ganyan siya, di ba? But this thing is between 0 and 1. By the previous case, anong limit nito? 0. Kung ang limit ng distance nung a to the n at 0 ay 0, anong limit ng a to the n? 0. So it follows directly from the previous case. Okay? So that completes the proof. Meron akong in-add na definition dito. No. Sometimes, the terms of a sequence tends to get larger and larger without bound, no? Or smaller and smaller without bound. So, in that case, we say that x sub n diverges to infinity. We do not say converges to infinity, ha? That's weird. Kasi first of all, pag convergent ang sequence, dapat bounded siya. If a sequence tends to infinity, that's not convergence, no? Ang tamang term natin doon, the sequence diverges to infinity. Well, there are other ways that a sequence can diverge. For example, naalala nyo itong sequence na to. Diba? This is another way to diverge. Hindi niya alam kung kanino siya sasama, kung sa 1 or sa negative 1. This is what you call as an oscillating sequence. Right? This is an oscillating sequence. Pero for example, yung sequence na 1, 2, 3, 4, 5, 6, etc. Yan. This is also divergent, not because it's oscillating, but because it's unbounded. In particular, in this case, this sequence, the values of this sequence tends to infinity. Anong sabihin nun? Papalaki ng papalaki without bound. What do we mean by that precisely? So this is what we mean. If you will give me any m greater than 0, so ganito yung picture niya. Pag meron kang sequence na nag-increase to infinity, ganyan ang itsura, di ba? Dire-diretso siyang ganon. Sabi ng definition, if you will give me any positive m, however large, no ba ito yung m, there will come a time na there will exist an n so that beyond that, yung mga terms mo are bigger than n. In fact, dun sa aking picture, nangyari yung n dito, di ba? Mula dyan sa n na yan, pakanan, nasa ibabaw ka na nung red line. Meaning to say, kahit gaano kataas yung m na yan, there will come a time that the terms of the sequence will exceed m. That's the definition. In this case, you will see me write this expression. Ano namang ibig sabihin when we say that the sequence diverges to the other side of infinity? Nangyayari yun if the negative of the terms, no, tends to positive infinity. Okay? Ganun lang, kadali. These are easy to prove, but I will not be doing the proof anymore. If you have two sequences, xn, y sub n, they both diverge to infinity, then their sum and their product diverges to infinity. Take note, warning, mag-iingat kayo sa subtraction tsaka sa division. Kasi if both x sub n and y sub n tend to infinity, yung x sub n minus y sub n, we don't know anything about it. It could diverge, it could converge, it could whatever. No? Kaya nga yung x sub n minus y sub n, yung tanong natin, what about x sub n minus y sub n? Saan mapupunta ito? Okay? Para ka merong infinity minus infinity kasi. It's like asking that. No? The real answer to this is, we don't know. It depends from one case to another. Or it is a case-by-case basis. Sometimes it can converge, sometimes it can diverge, sometimes it converges to 1, sometimes it converges to 39. No? Kaya nga, we cannot give one decision for this thing. No? Whenever xn and yn both diverge to infinity. Wala tayong isang decision lang. This is something that we should decide case by case. No? Kaya nga yung sa calculus nyo na pambata, di ba, yung sinusulat nyo yung infinity minus infinity is indeterminate. Ang ginagamit na term dyan ay indeterminate. Kasi we cannot decide at once. Kasi to where would this converge will really depend highly on both of the behaviors of x sub n and y sub n. For example, if x sub n tends to infinity faster than y sub n, di itong difference na to may tend to infinity kasi naiiwanan ni x sub n si y sub n. Kung halimbawa naman si y sub n naman tsaka si x sub n, sabay ang paglaki nila halos. Yung difference yan could converge to 0 or to 1 or to whatever. It depends. parehas din yan doon sa x sub n over y sub n. Mag-iingat kayo. No? We do not have a decision for that because aside from this, itong infinity over infinity is one among the indeterminate forms. Kaya lang tinawag na indeterminate yun kasi wala tayong decision or wala tayong fixed na decision. Hindi kagaya na ito. Hindi kagaya na ito. Alright? And as a corollary to the monotone convergence theorem, again, when we say corollary, it's a consequence, direct consequence. A monotone sequence either converges or diverges to either infinity or minus infinity. Why is that? Kasi ganito. If you have a monotone sequence, dalawa lang ang pwedeng mangyari. Pwedeng siya ay bounded or unbounded. Kung ang monotone sequence ay bounded, sabi ng MCT, convergent. Kung unbounded siya, may dalawang subcases na mangyari. Kung yung monotone mo ay increasing at unbounded, dito yun magda-diverge. Kung yung monotone sequence mo ay unbounded tapos decreasing, dito yun magda-diverge. Kaya yan lang ang possibilities when we consider monotone sequences. The only way for it to diverge is to either diverge to infinity or minus infinity. Do you get what I mean to say? Can I hear somebody? Mamaya, daldal ako ng daldal dito. How about the others? Dalawa lang nagre-respond. Michael, yes, thank you. Ang monotone sequence, ang sinasabi nito, ang mensahe talaga nito, there are just two ways a monotone sequence can diverge. Either it diverges to infinity or it diverges to minus infinity. It cannot oscillate kasi nga siya ay monotone. Did you understand?
Yes, sir.
Okay. So I think we can now define, at this point, we can now define what we mean by a subsequence. Do you have questions so far before I proceed? Okay, take time to think about some questions before I proceed with this. None po so far. Okay.
Sir, ako po.
Who is that? Sino nagtatanong?
Alan po.
Alan, yes.
Sir, kasi inisip ko po, kung sa kanina sa examples niyo po ng mga divergent, so there's oscillating there. Those that diverge to positive infinity and negative infinity. So I was thinking, meron pa po pong divergent na iba pa. And tama po ba itong naisip ko na sequence defined po na, example lang po is sequence defined by each digit of pi lang. Parang divergent po sa tama. Although hindi rin siya either of those cases.
Sequence of digits of pi. Yun ba yung sabihin mo? I think that diverges, yes. But it diverges because it diverges. It doesn't diverge because it goes to infinity or it oscillates. It simply diverges because it doesn't tend to anything. Kasi alam nyo, you can prove, ito yung binibigay ko as a problem set minsan. If you have a sequence of integers, kasi integers ang terms ng sequence mo na yan, di ba? Yung digits of pi. If the terms of a sequence are all integers, the only way for that to converge is that for it to be eventually constant. When I say for that to be eventually constant, dapat after some time, magre-remain na sa isang integer yung sequence mo. It cannot converge in any other way. Kaya, for example, yung sequence of the digits of pi, it cannot converge kasi kung yun ay sequence of integers, the only way for it to converge is that after some time, titigil na siya sa isang digit. Yun lang yung tanging paraan. Kaya, for that example, yung sequence of digits of pi cannot converge. Na-spoil tuloy. Problem ko sana yun sa next na problem set. If the terms of a sequence are all integers, no? At siya'y nag-converge, it follows that eventually it's a constant sequence. When you say eventually, may not be now, no? Sa umpisa maaring erratic yung behavior niya, but eventually dapat mag-stay siya sa isang integer. Kasi integer lang ang ano eh, ang terms mo eh, 'di ba? Did I answer your question, Alan?
Yes, po, sir. So ibig sabihin na it follows then na if the sequence is integer, then kailangan integer din po ang maging control.
Yes. A sequence of integers cannot converge to a non-integer. Very good. That's a good observation. Alam niyo bakit? Yung set Z of integers, bakit ang sequence of integers can only converge to an integer? Alam niyo bakit? Kasi when you try to construct or when you try to consider the complement of Z, ang complement nito union ng mga open intervals. Paano ko ba susulat to? Ganyan na lang. Kasi ganyan na. Pag binura mo yung integer sa real number line, parang ano to, yung usual na ano, yung usual na number, ay, wait lang. Yung usual na ano, na putol-putol. Ang ganyan. Ayusin ko na yung drawing ko yung buhay ko. Yan. Ito yung -3, -2, -1, 0, 1. Yan yung complement ng integer. Yung complement niya ay union ng mga open intervals na ganito over all n in Z. Dahil ito yung mga open intervals, open set yan, yung union na ito ay open. Kaya itong complement na ito ay open. Anong sinasabi niyan about Z? Z is closed. Anong alam natin tungkol sa mga closed set? Kapag may sequence ka sa loob ng isang closed set at yan ay nag-converge, ang limit dapat nandun sa same na closed set. Do you remember that theorem? Kaya if you have a sequence of integers, the only way for that to converge is that to converge to an integer. And to converge to an integer, where the terms are all integers, ang kailangan nun eventually constant. That's one way to explain. Did I answer your question, Alan?
Yes, po.
Okay, thank you. So let me erase this one. Kaya dapat yung mga concepts na yan na dinidiscuss natin sa room na ito, no? They are not really totally independent concepts. May mga closed sets, mga convergent sequences. Makikita nyo later, magtatagpo-tagpo sila in one meeting place. Kasi they really have connections. Especially pagdating natin sa mga continuous functions. Naku, yung mga continuous functions na yun, they preserve a lot of things. Anyway, we will continue. So pag sinabi kong subsequence of a sequence, ano lang naman yan? It's just a sequence that can be found in a larger sequence. But of course, ano yung sabihin ng can be found? Hindi naman set ang isang sequence, di ba? So it cannot be a subset. Paano mo i-define? Remember, a sequence is a function whose domain is the natural number. So if you were to have a subsequence, how would you define that? So this is the one way to define it. So ito yung given na sequence mo. The index is n, starts at 1. In reality, hindi naman kailangan mag-start sa 1 ha. I am just choosing 1 as the first index. But in reality, you could start at 2, could start at 39 if you want. It doesn't really matter. Gagawa ko ng another sequence. Tawagin kong n sub k. This time, this is indexed by k, starting from 1 to infinity again. N sub k is a strictly increasing sequence of positive integers or indices. Plural ng index. Kumbaga, yung n1, yung n2, yung n3, sequence of indices. Diba? 2, 5, 7, 11, na gano'n. Ha? the sequence defined by the following, nakita nyo, no? Yung subscript nung x, yung nk, k from 1 to infinity. So essentially, the new sequence is now indexed by by k. Ang terms na ito, xn1, xn2, xn3, makikita nyo in this example. Huwag na natin tignan itong definition na ito. Tignan na natin yung example na ito. No? Halimbawa, when I try to list down some of the terms of this sequence, they are as shown. All right? Can you check if the terms are correct? Tama, no? 1/2, 2/3, 3/4, 4/5, 5/6. In fact, alam natin ang limit nito. What do you think? This is convergent, right? To what limit? Anybody? Although it's not our business to calculate limits here, sa tingin nyo, saan magko-converge ito? How would you rewrite this? Yes, the answer is 1. Kasi you could write this as follows. You can factor n from here. You get this. Let's divide mo. So, as n approaches infinity, ito yung mawawala. Kaya ang limit ay 1. Yes. Ito yung sinasabi ko. Gagawa ko ngayon ng strictly increasing sequence of indices. Halimbawa, ang nk ko ay 2k. Pag nilista ko yung nk, ang n1 mo ay 2, ang n1, n2 mo ay 4, ang n3 mo ay 6. So ito ay 2, 4, 6, 8, 10. Ano yung 2, 4, 6, 8, 10? Sequence of subscripts to. Di ba? Yung sequence of subscripts. Siya ngayon yung gagawin kong subscript nung subsequence. What do I mean by that? Ito siya. Yung xnk, k from 1 to infinity, has terms xn1, xn2, xn3, xn4. Substituting these values for the nks, ito nalabas, x2, x4, x6, x8, etc. Nakikita nyo, no, lumalaktaw-laktaw. So, ano ba x sub 2? 2/3. X sub 4? 4/5. X sub 6? 6/7. Makikita nyo, you will find that this sequence is embedded inside this bigger sequence. In fact, they are colored yellow. Okay? So, did you see that? Ang gusto ko lang sabihin dito, meron lang tayong isang rule sa pagko-construct ng subsequence. Pag nagko-construct ka ng subsequence, para kang namamalengke doon sa original na sequence. Kukuha ka ng infinitely many terms ng sequence mo. In a way, no, ang tanging rule lang, pag kumuha ka na dito sa pang-apat, bawal ka nang bumalik. Bawal ka nang kumuha ulit doon sa likod. Dapat ang susunod na kukunin mo, laging nasa kanan. Remember, strictly increasing kasi itong sequence of indices. Strictly increasing meaning to say, pag nilagpasan mo na, wag mo nang babalikan. Parang pag-ibig lang yan, di ba? Pag inayawan mo na, wag mo nang balikan. Bawal yun. When you are forming a subsequence. Do you understand? Let the other person move on. Charot. Sir, tama bang sabihin infinite subset of a sequence? Ito nga yung sinasabi ko. Sir, tama bang sabihin infinite subset of a sequence ang subsequence? No. Kasi in the first place, a sequence is not a set. A sequence is different from a set of numbers. Kasi for example, you could have a constant sequence like this, but it's not considered to be a set, or as a set, it's just a singleton. But as a sequence, it has infinitely many terms still. Although the terms are all equal. Did you understand? Pag kasi sequence, may order tayong sinusunod. Pag set, wala. Okay? Alright. As a quick remark, every subsequence of a convergent sequence converges to the same limit. Siyempre, mana-mana yan, no? Kinuha mo, namalengke ka lang naman sa isang convergent na sequence ng mga terms. hindi ka naman bumabalik. Di ba? Ang rule nga sa pag-construct ng subsequence, kapag hindi mo na pinili, nilagpasan mo na, huwag mo nang babalikan. So, if you follow the pattern of the given sequence, kung yung given sequence ay nagko-converge to 5, lahat ng subsequence na magagawa mo doon, magko-converge din sa 5. Mana-mana lang yan. Minamana ang convergence. Yan. Kuha tayo ng subsequence ng x sub n. At kunwari yung x sub n ay nagko-converge sa x as n approaches infinity. So sometimes I write this as an emphasis, no? Emphasis ito na ang index nito na gumagalaw ay n. Kasi when you try to compare it with the subsequence, ang index nito ngayon ay k. Si k ang gumagalaw from 1 to infinity. Kaya later makikita nyo, as k approaches infinity, as n approaches infinity, magkaiba yan. Yung k approaches infinity, karaniwan para to sa subsequence. Yung n approaches infinity para doon sa buong sequence. We will now show that the subsequence x and k converges to x as well as k approaches infinity. Nakita niyo yung difference, no? Yung counter nung original na sequence ay n, pero ang counter nung bagong sequence mo ay k. As usual, let epsilon be greater than 0. Ano kailangan mangyari? Kailangan mangyari. Kailangan makahanap ka ng n such that yung distance na itong dalawa can be made less than epsilon. Basta, ano yung index natin? K. Did you understand me? Ayan yung kailangan mangyari. Makahanap tayo ng n, o sometimes hindi n ang ginagamit ko, sometimes big K. Para lang kamukha ng little k. No? Pero it doesn't matter kung anong letter ang gamitin nyo naman. As long as it's not a conflicting notation. Sometimes kasi nagamit mo na yung n for something else, as gagamitin mo ulit siya. That's not allowed. Sometimes it's a matter of choosing, well, ano ba to? Because we are under the assumption that x sub n converges to x, biyaya na itong convergence na to yung n na ito, no? Because of that convergence, we can select an n, no? So that we can force x sub n to be this close from x as long as the index is larger than capital N. Definition lang yan na ito. It turned out na yung n na ito, kung ano yung n na nakuha mo dito, gagana rin yan para dito sa subsequence na ito. You'll see why. Pag kumuha kasi ako ng k exceeding n sa kanan ng n, you'll see that n sub k is an integer bigger than or equal to k. Why? Kasi yung k mo, ganito. Yung k mo, 1, 2, 3, 4, blah, blah, blah. Yung nk mo, n1, n2, n3. Now, remember, ang nk, it doesn't have to even start at 1. No? Ito yung lumalaktaw-laktaw. Ito yung lugar kung saan ka namamalengke ng mga terms. If this is strictly increasing, for example, kung ang n1 mo, sinimulan mo na sa 2, di mas malaki na siya kagad sa 1. Yung n2 mo, laging mas malaki yan sa 2 at least. Di ba? n3 mo, mas malaki sa 3 at least. Kasi ito pwedeng lumaktaw. Do you understand? Kaya itong inequality na to lagi yung nag-hold. Si n sub k is at least k. And because k is greater than or equal to n, nk is at least n as well. But according to this implication, if you have anything bigger than n, nilagay mo dito, maging less than epsilon yon. Kaya, kapag yung n na to is replaced by nk, yung n na to will be replaced by nk, you will have this. Ganun lang siya kadali. Kaya nga, ito, highlightin ko ulit. Paano ba highlight? For every epsilon greater than 0, there exists an n such that if k is greater than or equal to n, if you look at these highlighted portions of the proof, that proves that x and k no, converges to x as k approaches infinity. Anong consequence na ito ngayong remark na ito? Sabi, kapag subsequence ka ng isang convergent na sequence, dapat convergent ka rin, in fact, to the same limit. Therefore, kung ang subsequence mo, kung ang sequence ay may subsequence na nagda-diverge, what does it say to the mother sequence? Of course, the mother sequence has to diverge. Kasi kung convergent yung mother sequence mo, dapat lahat ng subsequence niya convergent. Kaya kapag nakakita ka ng isang subsequence na isa lang no, na nagda-diverge, alam na this, divergent din si mother, you can use that. You can use that parang parang as a guarantee na yung sequence ay nagda-diverge if you can find parts of it that diverges. I will give you an example. Look at x sub n, who's defined by n with exponent negative 1 raised to n. Gulo, no? Sige nga, ano yung first term na ito? Oh, by the way, when I write a raised to b to the c, what we actually mean by this, by convention, is this. Ang exponent ng a ay yung cth power ni b. Do you understand? That's what I really mean by kasi some others may think na ito ay a raised to b raised to c, no? No. Pag sinusulat ng ganyan, ang a raised to b raised to c, ang parenthesis mo nandun sa exponent by convention. Okay? So, what's the first term of this? 1 is the first term. What's the second term? 2 raised to negative 1 squared, 2. Okay? 3. Ano yung negative 1 cube? Muna. Negative 1. So, 3 raised to negative 1, 1/3. Okay. N is 4. Negative 1 to the 4th is 1. 4 raised to 1, 4. N is 5. Negative 1 raised to 5, negative 1. 5 raised to negative 1. So, parang ano lang naman ito. Parang meron ka ng 1, 2, 3, 4, 5, 6, 7, 8. So, may mga exponent ka na papalit-palit sa negative 1 at 1. Did you understand? Parang 1 to the negative 1, 2 to the 1, 3 to the negative 1, 4 to the 1, 5 to the negative 1, 6 to the 1. Do you understand? So, this is our sequence. Okay, can you judge if the sequence is convergent or not? Can we say that the sequence is convergent? Anybody?
No, sir, I think no.
Yes, Alan, no. Why?
Sir, if we take the yung subsequence na 2, 4, 6, 8, 10, then I think we can show na that subsequence diverges.
Very good. That subsequence 2, 4, 6, 8, 10, 12, etc. Nandyan yan sa loob ng sequence, di ba? It will diverge to infinity. Therefore, divergent. Kaya yung subsequence itself cannot converge. Kasi sabi nga natin, if the mother sequence is convergent, dapat lahat ng subsequence niya will converge to the same limit. And you were right. Ito yun. Di yan yun. Nakalimutan ko. Lilituhin ko sana kayo eh. Ipapakita ko sana tong subsequence na ito. No? Yung subsequence na ito ay 1, 1/3, 1/5, 1/7. Ito yung mga odd terms. No? Convergent to 0. No? You'll see. Pero yung subsequence na to, divergent to positive infinity. Lilituhin ko sana kayo but I forgot to show you this one. Convergent ba to divergent? Kahit na meron kang subsequence na convergent, no? Kahit na meron kang subsequence na convergent, it will not guarantee convergence of the mother sequence. Okay? Pero pag may isa ka ng divergent na subsequence, automatic siya ay divergent. Ang katotohanan kasi kanina, pag yung sequence, mother sequence ay convergent, then lahat ng subsequence ay convergent. Yun yung katotohanan. Pero wala akong sinabi na kapag may subsequence ka na convergent, wala akong sinabi na pag may nakita kang subsequence na convergent na. No. Parang ano yun, you are concluding something for the whole just because one of its part is true. Parang gano'n, no? Naintindihan niyo ako doon? Parang what's true for some may not be true for all. So the answer is no. Kasi nga, we were able to find one subsequence that is divergent. So if the existence of this does not guarantee convergence. What is this recall? A convergent sequence is bounded, right? A bounded sequence may not converge, however. We all know that, right? Tama ba? What the hell is this? But according to this people, every bounded sequence has a convergent subsequence. Naintindihan nyo? Sige. Please take time to read this. Sabi natin, ang convergent na sequence ay laging bounded. Pero hindi lahat ng bounded sequence ay convergent. Pero kahit na hindi convergent ang isang bounded sequence, wag mo siyang itatapon fully kasi may mapapakinabangan ka sa kanya. Kasi basta ang sequence ay bounded, kahit hindi yan convergent, sure tayo na isa sa mga subsequence niyan ay convergent. Did you understand? Kumbaga, yung as long as the sequence is bounded, pwede mong itapon yung or burahin yung ilang mga terms so that what remains is a subsequence that is now convergent. Parang ito. Look at the sequence -1, 1, -1, 1, -1, 1, etc. If I'm going to erase the odd terms, di ba? What remains is a constant sequence which naturally convergent. So kumbaga, ang sinasabi ko dito, the next best thing after convergent sequences are the bounded sequences. Okay? So a bounded sequence may or may not converge. And even if it does not converge, you can still, ano bang English term na? You can still salvage some yung salvage, hindi ito yung salvage na papatayin ha. Salvage as in the original meaning. You can still get something from it. Parang yung tira-tirang ulam, iluto mo ulit. Sasarap ulit siya. Parang gano'n. So, even though a bounded sequence may not converge, may makukuha ka pa sa kanya. Sabi netong dalawang to, may makukuha kang subsequence sure na magko-converge. And this is actually a theorem. This is one of the main theorems in advanced calculus. And this theorem was named after these two mathematicians, Bolzano and Weierstrass. Yung pangalan ni Weierstrass may German letter na ganito. No? Ano to eh? Sa English, tinatranslate siya as ano? Parang SS. Mga German, yung S niyan yung medyo mahabang S. Weierstrass. Si Bolzano, I think, ano to eh? Italian monk siya. In fact, sa Italy, merong isang city or town, maliit na city na pinangalan sa kanya. I have been there before. So, meron siyang parang rebulto doon na kung ano. Yeah. Si Weierstrass, kasama ni Bolzano, actually hindi naman sila nagkita eh, hindi naman sila magkakilala sa totoo. Tingnan nyo kung kailan sila pinanganak. Diba? Hindi sabay. Although, siguro nag-overlap yung mga ano nila, yung mga time nila sa Earth, pero I don't think na magkakilala sila. It just so happened that they both work with these foundations of calculus. And I don't know why this theorem was named after them. I don't really know. It's not because hindi sa math no, hindi porket pinangalan sa isang mathematician ng isang theorem, it doesn't necessarily mean na siya ang unang nag-prove or siya unang naka-observe. Sometimes theorems are named after some mathematicians just because we want to honor them of their contributions. Maraming contribution si Weierstrass definitely, tsaka si Bolzano sa ano. I think ang isa sa mga contributions ni Weierstrass na pinakamalala yung ano, yung extreme value theorem later. Sabi ng extreme value theorem sa calculus, kapag ang continuous function ay may compact na domain, ang domain niya ay compact, sure ka na yung function na yun ay may maximum at may minimum. Mag-a-assume siya ng maximum at minimum values. Kasi hindi laging ang function may maximum at minimum. Pero pag ang continuous function daw ay mayroong compact na domain, sure ka na may maximum at may minimum. Ayan, isa yun sa mga contributions ni Weierstrass. He was able to prove that. He was able to find that condition, yung compactness tsaka continuity. Pag nagsanib pala sila ng puwersa, marami tayong pwedeng i-conclude. Matututunan natin later yan. Then, si Bolzano, he was attributed for his work in yung tinatawag na intermediate value theorem, kung alam niyo yun. If you have a continuous function on an interval, halimbawa, I will give you one example. Application. Alam mo yung temperature for today? Continuous yun eh. As a function of time. Kunwari ito yung time. Ito kunwari yung temperature. Okay? Let's say, ngayon ay 12 p.m. Tapos ito 5 p.m. Kunwari ito yung graph nung temperature. Siyempre mainit ng 12 p.m. No? Tapos as time goes on, at 5 p.m. medyo lalamig ng konti. So, kunwari ito 30 degrees Celsius. So, kunwari ito 25 degrees Celsius. According to the intermediate value theorem, at some time between 12 p.m. and 5 p.m., nangyari yung 27 degrees. Nangyari yung 27.39 degrees. Nangyari yung 29.32 degrees kasi yung mga values na yun are intermediate between 25 and 30. Lahat ng mga values intermediate between the endpoint values 25 and 30 naganap at some time between 12 p.m. and 5 p.m. Kasi nga yung function mo ay continuous in an interval. Ang tawag doon ay intermediate value theorem. We will talk about that later. And it has a lot of applications as well. Halimbawa, alam nyo ba, at any given point in time, laging may dalawang point sa surface ng Earth na parehas ng temperature. And at the same time, they are on opposite poles. What do I mean by that? Diba may Earth kang ito yung Earth mo kunwari. No? Assume na lang natin sphere. Lagi ka raw may makikita at any given time. Meron ka makikitang dalawang points na antipodes. When you say antipodes, parang they are on the opposite side of the Earth. At the same time, yung temperature are exactly the same. At any given time. Siyempre, habang umaandar yung time, yung dalawang points na yan, umaandar-andar or nag-iiba-iba. That's an application of the intermediate value theorem. I will show you later. Ang reason niya, hindi science, no? Hindi yan, tama. Endpoints on diameter of the sphere. Yeah. At any given time, laging may dalawang lugar sa Earth na parehas ang temperature, parehas ang pressure, no, kung ano man yung mga. Ang reason is not scientific, but it's actually mathematical. But before proving the theorem, ano yung theorem natin? Every bounded sequence has a convergent subsequence. Before proving the theorem, we need the following lemma. When you say lemma, it is a theorem that you prove in order to prove a theorem that you wanted to highlight. So if I wanted to highlight the Bolzano-Weierstrass theorem, no, because I needed this result for me to prove the Bolzano-Weierstrass, I will call this one a lemma. Okay? At itong lemma na to, it turned out na meron siyang pangalan din. Ang tawag dito ay nested intervals property. It has something to do with, naalala niyo yung Cantor's intersection property? Parang if you have a sequence of compact sets na papaliit ng papaliit, compact sila, yung intersection nila, hindi mauubusan ng laman. Did you saw this? Hindi mawawala ng element in the intersection. Meaning to say, there is a point that is present in all of this. Kahit na papaliit ng papaliit yung set. This is a special case. No? Tingnan natin to. Why? In is a sequence of closed and bounded intervals. By the Heine-Borel theorem, closed and bounded actually means compact in the real number line. Ganito yung tsura ng closed and bounded na interval. May endpoints na an, may endpoint na bn. Gumagalaw yung n. N goes from 1 to infinity. So nag-iiba-iba yung mga endpoints na yan. Such that yung in ay nasa loob ng in plus 1. What do I mean by this? So if I'm going to draw the number line, ito yung A1, B1. So yan yung I1. Diba? Where's I2? I2 should be, parang mali yung inequality ko. I think this is wrong. I think what I actually mean is that baligtad. Can you edit this one? Kasi I wanted that I2 be inside I1. So I wanted this to happen. So this is what I wanted to happen. So I2 is included inside I1. Ang I3 is included inside I2. And so on. Ang tawag natin dito ay nested sequence of intervals. Papaliit ng papaliit. Okay? Ito na yung theorem. If Bn minus An, ano yung Bn minus An? Yung Bn minus An, ang tawag natin dyan, yan yung length. No? We call this the length of the interval. Kasi it measures the length of the interval In. No? If the length of the intervals gets smaller and smaller to 0, papaliit ng papaliit ito. No? Ano raw ang matitira sa intersection? Definitely by the Cantor's intersection property, there will be something in the intersection. But because the sizes of these intervals get smaller and smaller to 0, the only thing that will be left in the intersection is a single point. Did you understand? There will exist an x0 in the line where the intersection of these INs is the singleton that contains x0. Isang point lang daw may iwanan na present sa lahat ng IN. Did you understand this? So let me explain the proof to you. What the hell? Heine-Borel theorem. Dahil nga lahat ng IN ay closed and bounded by the Heine-Borel, they are all compact. At dahil yung I1 contains I2, I2 contains I3, and so on, by the Cantor's intersection property, we already know that this intersection is not empty. So hindi na natin kailangang ipakita na non-empty ang intersection. What we just wanted to show at this point is that yung intersection can only have one point in it. No more than one point. Okay? And how do we show that? By the way, of course, under the assumption that the length is my God, but infinity to. I'm so sorry. Maybe I am already sleepy while typing. This is light. 0 yan, ha? We are under the assumption that this length is going to 0. Oh my God. So to prove that there's only one point in the intersection, I will pick two elements in it, x1 and x2. Ang aking ipapakita is that whenever I pick 2 points x1 and x2 in the intersection, I needed to show that they are equal. Do you understand why I wanted to do this? Because I wanted to show uniqueness. So kumuha ko ng dalawa, I will eventually show that they are equal. At dahil tayo nasa advanced calculus or real analysis, no? Ang proof, lagi nag-start sa let epsilon be greater than 0. Ang gusto ko mangyari dito, no? In the end, blah, 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 blah. Ang mangyayari dyan in the end, ito. I will show that the distance between x1 and x2 will be less than epsilon. Kasi if epsilon is an arbitrary positive number, and then the distance between x1 and x2 is less than any positive number, therefore the only choice for the distance left is 0. And that proves that they are equal. Tawag natin dito epsilon property, di ba? Okay, so this is epsilon property in action. So let's see. 0 to. Naiinis ako. Naiinis ako sa infinity na yun, ba't sumingit? Gagamitin ko yung fact na ito ay nagko-converge sa 0. Dahil nga nagko-converge sa 0, we can select one index where this distance is already less than epsilon. That will eventually come out. Kasi nga nag-0 ito eh. Kaya yung length na yan eventually will be less than epsilon. Pipili ka ng ganong n. Tingnan nyo ngayon yung interval na in. Yung interval na in na yan, ang endpoints niyan, a sub big N, b sub big N as shown. Dahil yung x1 and x2 nandyan sa intersection, ibig sabihin sila ay nasa lahat ng in. In particular, they are both in I big N. Okay? How about their distance? Parang ganito yan eh. Ito yung in. And nandyan daw silang dalawa. Nandyan yung x1 at x2. Alam nyo, kahit saan sila nakakalat dyan, ang distansya nila hindi lalagpas sa distance ng AN at BN, which is BN minus AN. But how did we select N? We have selected N so that BN minus AN is less than epsilon. So eventually, I was able to show that for every epsilon greater than 0, this is less than epsilon. Epsilon property now guarantees that x1 should be equal to x2. That proves the theorem. So the only thing left in the intersection is at least 1 point. At most 1 point, sorry. So, naintindihan niyo na sa interval property, ha? We will be using that now to prove the main theorem in this lesson, which is the Bolzano-Weierstrass theorem. What does it say? Every bounded sequence may converge or may not. Kung converge, di tapos na. Kung hindi, meron kang subsequence na sure na magko-converge. Why is this theorem celebrated? Or why is this important at all? Kasi yung, first of all, yung proof nito is very, yung kauna-unang gumawa ng proof nito ay napakagaling. Kasi, kung isipin mo, sige, may bounded sequence ka. Saan kamay ng Diyos mo kukunin yung subsequence na nagko-converge, no? How will you exhibit such a convergent subsequence? It's kind of hard to think about at first, no? But this method is ingenious. Tingnan nyo. Start tayo sa assumption na si x sub n ay bounded. Being bounded means that you can find an m greater than 0 so that the absolute value of x sub n is less than or equal to m for all n. Again, ang meaning nito, yung lahat ng terms ng sequence mo can be found in some closed interval from minus m to m. So, balikan nyo lang yung definition natin ng bounded. Yan yun. Excuse me, wait a minute. Okay. Yung buong interval na yan, sabayan natin kasi ng drawing. Mamaya na. Yung buong interval na yan, tawagin natin I1. Tapos, iset natin yung N1 as 1. Kasi yung proof nito ay algorithmic. Parang naglalagay tayo ng initial value sa variable na I1, para ka nagpo-program. Naglalagay ka ng initial value sa I1, naglalagay ka ng initial value sa N1. Okay? Yung I1 natin, siya yung interval from minus M to M, yung N1 siya yung number ng 1. Gagawin ko, yung interval na I1, hahatiin ko sa dalawang closed subintervals of equal length. Ugupitin ko sa gitna. Eh di ba ang gitna niyan 0? Can you imagine it now? Ito yung original na interval kung saan lahat ng terms ay nandito. Of course, nandiyan yung 0. Gugupitin ko siya sa dalawa. Ito yung I1 prime. Ito naman yung I2 prime. Sabayan nyo ng drawing sa isip nyo. I1 double prime, I'm sorry. Sa first step pa lang kasi tayo. Now, lahat ng terms ng x sub n nandito sa interval na ito, right? So, if this, if I1 consists of I1 prime and I1 double prime, dapat isa dito sa dalawa ang magko-contain ng infinitely many terms ng x sub n, right? Kasi lahat ng terms nasa I1. Kung binubuo ng I1 prime at I1 double prime yung buong I1, dapat maghahati ngayon yung yung sequence mo sa dalawa, no? Kasi nahati sa dalawang part yung buong interval mo. So one of these intervals, subintervals, must contain infinitely many terms of x sub n. Why? Kasi if they both only have finitely many terms, ibig sabihin nun, ang union na itong dalawa si I1, ibig sabihin nun, I1 will only contain finitely many terms of x sub n, which is not, kasi lahat ng terms or all those infinitely many terms are here. Kaya hindi pa pwedeng pares finite lang ang laman na itong dalawa. One of them must contain infinitely many terms. Kung sino yun sa kanilang dalawa, kung sino yung mananalo dun sa dalawa, sino, or pwede kasing parehas silang may infinitely many terms, mamili ka lang ng isa. Tawagin mo yun as I2. So parang ganyan yan. Original, ito si I1, hinati ko sa gitna. Kunwari, ito yung nagwagi. Kunwari, ito yung nagko-contain ng infinitely many terms. Tatawagin mo yan ng I2. We will continue the process. Hahatiin ko ulit ito sa gitna. Because the original one contains infinitely many terms. Again, each one of these will have infinitely many terms. Kung sino man sa kanila, or kung pares man sila, mamili ka lang ng isa. Kunwari, itong nanalo, tatawagin mo siyang I3. And you will keep on doing the process indefinitely. But, meron tayong intermediate na step. Before you repeat the process, tinawag mong I2 yung nanalo dun sa first step, no? Sa first na banggaan ng dalawang intervals. Pipili, kasi nga si I2 ay may infinitely many terms ng sequence. Makakapili ka, ito yung N1, no? Makakapili ka ng isang index bigger than N1 so that xn2 belongs to I2. In other words, makakapili ka ng isang term ng sequence na nasa I2. Kung saan yung subscript ay mas malaki dito, of course. Kasi 1 yun. Maraming index ang mas malaki sa 1. So that x sub that index belongs to I2. Ito na yung second step. Hahatiin mo ulit yung interval na I2 into two closed subintervals of equal length. We will call them I2 prime and I2 double prime. Again, maglalabanan yung I2 prime tsaka I2 double prime. Ano yung criteria para manalo? Kailangan one of them kung sino yung magko-contain sa kanilang infinitely many terms, siya ang mananalo. Now, it could be I2 prime is the winner, or I2 double prime is the winner, or they could contain both infinitely many terms. In that case, tie sila. So, kunwari na lang, kung sino man yung mananalo sa kanila, tawagin natin yung I3. Again, because I3 contains infinitely many terms, you can select one term from I sub 3 whose index is bigger than the old index n sub 2. Kasi you have infinitely many choices. That's the idea. So we just continue to repeat the process, obtaining a subsequence xn1, xn2, xn3. Now, ang rule, yung xnk nasa I sub k. Diba? Observe that I1 contains I2. In fact, hinahati mo lang ng hinahati, di ba, to get the next interval. And the length of the interval in, how long is the interval in? Oh my gosh. Sige nga. How long is I1? Yung original. Let's go back to that slide. How did I construct I1? Where should I get that? Okay. Yan. Sige nga, how long is, ito yung I1. How long is I1? How long is this? Can you calculate the length? Anybody? Anybody calculate the length? Paano ba nagko-calculate ng length? Di ba right endpoint minus left endpoint? Anong right endpoint? Hello? Are you still there?
Yes.
Sige, anong right endpoint minus left endpoint? Ito, original. M? Ano? M minus negative M. So, anong length? 2M. Very good, 2M. So, let's go back. Saan na ba tayo? Okay, nandito tayo eh. Ang length ng I1 ay 2M. Ang tanong ko, anong length ng I2? Ginupit ko sa gitna si I1 to get the I2, di ba? So, dinivide mo sa 2, which is M. Anong length ng I3? Di-divide mo ulit si M sa 2, di ba? I4. May pattern yan. Okay, di ba? Ito yung length. 2M divided by 2 raised to M. Agree? Kasi you have already divided the original length by 2 n times. You can rearrange it as follows. 2m times 1/2 raised to n. What do we know about 1/2 raised to n? This thing converges to 0. Kasi 1/2 has an absolute value less than 1. Kaya ito'y constant lang naman. It will not matter. So the entire length will go to 0. So what does the nested interval property has to, I think NIP has to say something about that. Yung mga intervals na yan will only have one point in the intersection. Let's call that one point as x naught. Ito na. Ipapakita ko na yung subsequence na ginawa natin, magko-converge dun sa nag-iisang point na nandun sa intersection. Kasi ganito yan eh. Kaya nyo i-picture yan sa isip nyo. Ito yung I1. Nandyan si XN1. Okay? Pinati ko sa dalawa. Kunwari ito yung I2. Nandito si XN2. Gawin nga natin blue. Nandito si XN2 sa I2. Hatiin mo ulit sa dalawa. Kunwari ito yung I3. nandito sa xn3. Every time yung xnk nasa ik. Pag hinati mo na hinati yan, isang point nga yung matitira. Yung mga blue points na yan will converge to that intersection. So that's what we are going to do next. Ayan. We now claim that xnk converges to x naught as k approaches infinity. If we were able to do this, we are done. Kasi from a bounded sequence, nakapag-construct tayo ng subsequence na nagko-converge. Brilliant, di ba? Let epsilon greater than 0. Dahil nga yung length ay papaliit ng papaliit, you can find a natural n so that pag yung subscript ay mas malaki sa n, yung length ay mas maliit sa epsilon. Kasi sa 0 siya nagko-converge. I can force this length to be smaller than epsilon for k greater than or equal to n. Usual trick. Pag kumuha kami ng k bigger than n, yung nk normally will be at least k, therefore it's also bigger than n. Hence, dahil yung xnk at x naught, ganito. By default, yung xnk nasa ik. Yung x naught ay nasa intersection. Pag nasa intersection, di ba nandun din yun sa ik? Kasi ang intersection, si ik ay isa sa mga nakiki-intersect to get the intersection. Kaya yung x naught nandun din sa ik. O imagine mo, ito yung ik. Ito si A. Huwag na natin pangalanan yung endpoints. Ito si ik. Nandito si x naught. Nandito si xnk. How large is their distance? Their distance cannot exceed kung ano man yung length ng ik, di ba? Kung ano yung length ng ik. But because of the above, this is less than epsilon. So if you're going to highlight, for every epsilon greater than 0, there exists an n such that if k is greater than or equal to n, this is less than epsilon. What does that say? X and k converges to x naught as k approaches infinity, and therefore proving the Bolzano-Weierstrass theorem. Lapit na tayo matapos. We're only 4 slides till the end. Okay? Naintindihan nyo yung how to construct the subsequence? Pero normally, we will not be doing that by hand kasi as you can see, the process is kind of hard to do by hand. But we know that it can be done theoretically. So tatandaan nyo, ang bounded sequence may not converge, but you are always guaranteed of a convergent subsequence. For this type of theorem, as you can see, it is one example of a theorem that guarantees the existence of something. Pero hindi niya sinasabi kung ano yun. Di ba? Ang tawag niya sa mga theorems na yan, existential theorems. Kasi they guarantee existence of something. For example, yung completeness axiom, that's an example of an existential statement. It tells you that the least upper bound exists, but it doesn't really tell you kung ano. Okay? In connection to this, we can now define the following terms. So here, you get a sequence. A sequence can have a limit. If it has a limit, convergent. Ang problema, it may not have a limit. Ang ating alternative ay limit ng isang subsequence if it doesn't converge. So pag sinabi natin subsequential limit of x sub n, it is a number S where a subsequence of the original sequence converges to S. Of course, by definition, if their sequence is convergent, isa lang ang subsequential limit niya, di ba? yung limit lang mismo. Kasi pag ang sequence ay convergent, lahat ng subsequence mo magko-converge sa same na limit. Kaya kapag convergent ang sequence, isa lang ang subsequential limit. Oo, tingnan natin. Another way to restate the Bolzano-Weierstrass theorem is using the following. No? Every bounded sequence has a subsequential limit. Lagi yan. It may not have a limit, but certainly it will have a subsequential limit because it will always have a subsequence that is convergent. We get the following definition. So meron akong sequence. Tawagin natin S. Lahat yung set ng mga subsequential limits na ito. Halimbawa, may subsequence na nag-converge sa 1. Ilagay mo si 1 sa S. May subsequence na nag-converge sa 39. Lagay mo sa 39 sa S. Yun. Si S, ipunan mo or basket, lalagyan mo ng mga limits na mga convergent na subsequence. Intindihan niyo ako? Halimbawa, yung sequence na -1, 1, -1, 1, minus, yung paborito ko example. What are the subsequential limits of this? It doesn't have a limit, but it has subsequential limits. Example, sige nga, can you give me one subsequential limit of this? Before we proceed with the other portion of the definition. Yes, 1 is a subsequential limit kasi it has a subsequence that converges to 1. It also has a subsequence that converges to -1. In fact, 1 and -1 are the only subsequential limits. Very good, Syra. Very good, Eric. Okay? So once you have collected all the subsequential limit, we get the following definitions. Kung bounded si x sub n, alam mo na si S ay non-empty. Di ba? So pag bounded yung sequence, Bolzano-Weierstrass guarantees that S has an element kasi meron siyang subsequential limit. Kung ano man yung infimum nung set na ito, yun yung tinatawag nating limit inferior of x sub n. Kung ano man yung supremum nung set na ito, ang tawag natin doon, limit superior. Kung finite lang naman yung S, yung infimum, minimum lang yun. Kung finite lang sa S, yung supremum, maximum lang yun, kung ano yung pinakamalaki. You don't have to worry about this. Pero, kung halimbawa, si x sub n ay may subsequence na nagda-diverge to infinity. Halimbawa, may portion siya nagpupunta na infinity. We will write the lim sup of x sub n to be infinity. At kung may subsequence naman siya na nagda-diverge sa negative infinity, we will write the lim inf as minus infinity. Itong last na statement, this is to cover the case when x sub n is not bounded. Kasi kapag hindi bounded sa x sub n, sure tayo na may subsequence siya na magda-diverge or magko-converge sa positive infinity or negative infinity. Okay? Let's consider this example. Can you list down some of the terms? Sige nga. What are the terms of this sequence? Ayan. Hindi ako mapakali. Ayan na. Yan na yung mga terms niya. When n is 1, cosine of pi over 2 is 1. When n is 2, cosine of pi, that's -1. When n is 3, cosine of 3 pi over 2 is 0. When n is 4, cosine of 2 pi is 1. Because cosine is 2 pi periodic, uulit lang ng uulit. 0, -1, 0, 1. 0, -1, 0, 1. See? So what are the subsequential limits? And then, na-spoil ko naman kaagad. So as you can see here, the subsequential limits are 0, 1, and -1 only. Because you can look at the subsequences. Yung x2k minus 1 for your information, ito yun. Ay, no. x2k minus 1, add ito eh. Yeah, ito. Yung x4k, nag-skip kada 4. Ito. x4k minus 2, ito. Okay? Therefore, ano yung lim-inf neto? -1. Ang lim-sup niya ay 1. Yung 0, ano? Wala lang. Subsequential limit lang siya. It's neither the lim-inf nor the lim-sup because the sequence has a smaller subsequential limit or a bigger subsequential limit. O, sige nga, ito kaya niyong gawin. Naalala niyo itong sequence na to? Lista nyo nga yung y sub n. Ito yung y sub n. 1, 2, 1/3, 4, 1/5, 6, 1/7, blah, 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 blah. Can you tell me what's the lim-sup? O lim-inf muna. Anybody? Anong lim-inf? Ano muna palang subsequential limits? Dahan-dahan. It has a subsequence converging to 0. Diba? So 0 is a subsequential limit. Is infinity a subsequential limit? No. No. Infinity is not a subsequential limit. But a subsequence diverges to that. Remember, ang subsequential limit ay limit ng isang convergent na subsequence. So isa lang ang subsequential limit nito 0. But yet, no? Hindi mo pwedeng sabihin kasi unbounded to eh, 'di ba? Sige na nga. Sulat na nga natin, huwag na natin sulat si S. Ang lim-inf niyan ay 0, pero ang lim-sup niya ay ano? Infinity. Okay? Kasi may subsequence ka na nag-diverge. Basahin ulit natin yung definition, ha? Kasi it might confuse you later. Ito kasi, ang definition natin ng subsequential limit, limit siya ng mali, hindi ito yun. Limit siya na isang convergent na subsequence. So in this case, kapag ganyan, sasabihin mo ang lim-inf ay 0 kasi may subsequence ka na nag-converge sa 0 at wala nang ibang subsequential limit. Diba? Pero ang lim-sup niya ay hindi 0 kasi meron siyang subsequence na magda-diverge sa infinity, namely 2, 4, 6, 8, etc. Okay? I hope that you get that. And this is the last slide. If your sequence is bounded, bounded, wala kang subsequence na nakakarating ng infinity or minus infinity. If your sequence is bounded, kailan siya magko-converge? Kasi ito na yung huling tanong. Kung hindi lagi nagko-converge ang bounded sequence, ang tanong, kailan siya nagiging convergent? May answer na tayo doon. Nangyayari yun precisely when the lim-inf and the lim-sup coincide. Kasi pag nag-coincide yung lim-inf tsaka lim-sup, isa lang ang subsequential limit mo. Diba? Yung S mo parehas ang infimum at tsaka supremum. Pag nangyari yun, singleton yung set mo. In other words, lahat ng subsequence mo doon magko-converge. Therefore, yung sequence mo magko-converge doon. Do you understand? In this case, nagko-coincide yung lim-inf, lim-sup, tsaka yung limit. I don't think I need to explain this even further, no? Kasi I think this is clear. Ang nagawa natin at this point is we were able to determine a condition. Kaya ako dinefine yung lim-inf at lim-sup. Kasi they will give us a condition kailan magko-converge ang isang bounded sequence. Kasi generally, ang bounded sequence ay hindi convergent. Pero with these conditions in mind, no? With this condition in mind, we can now guarantee convergence. And this is the only condition that we need to guarantee convergence for a bounded sequence. Okay, so did you learn something today? I think I have to pause the recording, stop the recording, and I will answer your questions.